This is the sixth assignment for chapter 13 in the text, and what we're going to be doing is populating a geodatabase with at least 4 feature classes and at least 1 feature data set. So there's a bunch of different ways we can do this, but what we've got here is the state of Michigan's data portal, and each state may or may not have some data available. Michigan happens to have a data portal that's been around for a number of years, and it's a handy resource for local data. So if you have some property or hometown or something that you want to make some maps of, this is a data source for data that will work in your ArcGIS software. So let's go there now. And so here it is. One of the things that's really interesting on this resource is this map projections link here. So actually I'm going to close that for a second and just open it up over here. So we'll come back to that in a minute, but it'll explain some things about map projections, which has some importance for our feature data set layer that we're going to be making. Anyway, let's choose a county. Okay, I'm going to just be a little boring and choose, not that Marquette's boring, but it's just one that's easy. So for me to know. So here we have all the different data that's available. You've got some air photos. These are called ortho photos sometimes. Census data. Now this stuff is for demographic work, and you can attach Census Bureau information to some of these census data sets, but the one that we'll work with for now is the Geographic Framework. So this is sort of a group of data sets that will make some base maps. And then there's other things like geology, hydrology, and you can go through the list. And there's also this new portal available as well, which may be better than what I'm doing now, but this is simpler for what we need. So if you are feeling adventurous, take a look at this portal sometime, and you can see that may be a different way of transferring data. So anyways, let's just go back to this. So I'm going to download this framework. It doesn't take very long. It's 14 megabytes, and it's going into my downloads folder. One thing that we should do right now what I usually do is I hit the little Windows key and the run command, and I'll type in Explorer, and this brings up your Windows File Explorer. So what we're downloading right now is a zip file, and you can see it, marquetteframework.zip, and it's gone into my downloads folder right here. So let me see if I can go, there it is. And if I double click on this, so I'm in downloads, double click on this, I can see that it's all it has a number of nested compressed zip file folders within that main framework zip file. So nested zip files within the main file, and in here we have census data, census tracts, and hydrology and transportation. I think hydrology and transportation are the ones that we would work with initially, I would say. So what you may want to do here is I would open up another Windows Explorer. So just hit run, or if you see you've got the link on the bottom, you can maybe go into your computer here. I don't know where this thing is, but that's why I always just type in Explorer. But I usually use it. Run Explorer. Used to be called My Computer, but you can use this. Now I keep my so GC335 on the C drive. You've got the MGIS data folder. You may not, maybe we'll use this, and we can create a new folder in here called Marquette. So this is going to be a place where we're going to be storing our data that we've downloaded. So we're going to create a structure just now to sort of organize our files. So within Marquette, I'm going to create a new folder called roads, and another new folder called hydrology. So this is giving us a structure okay, so if I go back to the actual assignment here, click back, you can see in this sample assignment this student had Baraga County, a hydrology folder, and a transportation folder. And within that, you can see he's got some hydrology data and some roads data. And then down here, you can see he's got a geodatabase, and then within that, a feature data set called hydrology, and another feature data set called transportation. So essentially, he's taken, as a student was a guy, and he's taken the hydrology data from here and imported it into this structure here. So we're going to be creating those things in a second here. So going back to hydrology and roads in Marquette, I go back to my zip file and I'll start with transportation. And this is roads. There's the railroads because Marquette has some railroads for the mines. And I'm just going to hit, let's see, I think I went to Control A, but oops, select all and then copy. Okay, so I'm basically taking all of these files. So a shapefile is a collection of files. All of these files, so you've got shape, so you can see all roads 103 version 14a shape, and then you can see a number of files with the same name, but with different extensions. So copy all of those. It's going to be some kind of error message, but that's fine. And put those in roads, okay? And then hit paste. And we'll go to hydrology here, and we'll go up one step into the framework. Not the transportation framework, but it's going to the hydrology framework, and we'll do the same thing. We'll just grab all of these files and copy them, and then paste them into our hydrology folder. So I mean, however you want to set up your structure is up to you. File management is sort of a personal thing, but good housekeeping, like anywhere, is you try to be organized so that other people or yourself at a later date will understand what you've done. So now that we've got our zip files inflated and separated out, we can actually work in ArcGIS. We don't actually have to have Windows Explorer open. Within ArcGIS, we have ArcCatalog, and that's the tool you guys have been using for managing GIS data. And so it kind of simplifies things. One of the things that you have to do with ArcCatalog all the time is right-click on the folder structures and hit refresh. And you can see now that I've got Marquette in here. Maybe it wasn't there a minute ago, but I just make a habit of refreshing it. And then you've got hydrology and roads, just like we just created a second ago. And then you can see the shape files, and it hasn't included all of those other pieces of information because it's trying to simplify it for the user. Now, if I right-click, so let's just grab the hydrology for a second. So there's the rivers in Marquette County, and there's some lakes. We'll go look at, I think this is Big Bay Lake, maybe Lake Independence. I'm not sure. We could actually query it and see what it says, Lake Independence. So just a little, and another thing you want to do with a data set is right-click on it and take a look at its properties. One of the main things you'll want to do is look at the source. And within the source, it tells you where it's been stored, so we know where it's been stored because we just created that structure. And then another piece of information is this projection data. It would be very similar to looking on a map and seeing what projection or spatial referencing systems are being used. So just make kind of mental note of that. And here we have Michigan's hot line Mercator. A little bit of a mouthful there, but we'll get back to that PDF file in a second here on the State of Michigan's data portal, and we'll see what that implies. So another thing you may want to do is just check the attributes just for so you can see there's square kilometers, square miles, acres, county, maybe the name of the lake here in the river. It's got some rivers, so you can get a sense of what's in this data set. So projection information, attributes, good starting point. The next thing we want to do is start to make our Geo Database. Now this is really important. So all of you guys coming out of GC 335 should, if you want to go on in GIS, you should start to know how to handle data sets. And the file Geodatabase is really what you want to be moving towards. The personal Geodatabase is actually a Microsoft Access structure, and it's okay, but it's sort of something that they're moving away from slowly, but it still lingers around. So create a new file, Geodatabase, and we'll call this Marquette. And within Marquette, we're going to be creating two new feature data sets. So this is where we're going to be creating new feature data sets to store our roads and our hydrology layers. So the first one's going to be called hydrology. And this is where things get a little bit tricky, but it's asking for a coordinate system. So every state, area, landmass around the world has a different shape and has different parameters for mapping. So this is important. So I was telling the students I've been seeing asking questions about this assignment, a little bit about the Michigan state coordinate systems. So Michigan has a state plane or planimetric. So a plane surface, or when you plane a piece of wood, it makes it flat. So a plane surface is a flat surface, and so you can have what's called a round Earth model, degrees, minutes, seconds, and a flat Earth model, which is a plane surface. And the flat Earth model is essentially using, instead of degrees, minutes, seconds, it uses measurements like feet or meters. And then you'll say to people, well, this location is so many meters away from that location. So it's an easy type of distance for people to understand. But what happens is, as you move away from the starting point of the grid or the coordinate system, so the origins, things start to get distorted. So they can only use flat Earth models for sort of small patches of ground. Otherwise, you start getting into lots of distortion, and your distances and so forth will be introducing error. So for things like property boundaries and surveying, they can't allow for too much error. So they break the ground up into patches or zones. And the state plane system in Michigan has 3 zones here. Another thing too that typically happens with areas is the parameters that we use to build our projections are based on an understanding of the Earth's shape. And this has changed, essentially, the understanding of it's changed over time. So back in the 1920s and earlier, you can see something saying 1886, they had instruments that were fairly accurate, and they had an understanding of the Earth's shape, and they came up with what's known as a datum, which is essentially a sea level value or a zero value for elevations, but it also provides the shape of the Earth. And then coordinates reference from the center of the Earth out to the skin or the shape, and positions are given X and Y coordinates on that shape. Well, that shape changed in the 80s. With the introduction of GPS, because with GPS they used space and laser measurements to redefine that datum, and so there's a new datum. So you've got the NAD 27, which is North American datum 1927, and then the shift was NAD 83. So you can kind of think of these things like a thermometer. Some thermometers reference Fahrenheit, some reference Celsius. The values, so let's say take the number 32. If I said the temperature is 32 degrees, it's going to be a totally different thing if I say, well, 32 degrees Fahrenheit versus 32 degrees Celsius. So think of these coordinate systems a bit like choosing some kind of way to tell your audience what those numbers actually represent in terms of positional accuracy. Or, like I said, if it was a thermometer, you'd have to say it's Fahrenheit or Kelvins or Celsius. So this is the state. Now, these 3 zones are kind of annoying because if you happen to be living right on one of those zone boundaries, or you straddle one of those zone boundaries, which can happen quite a bit, especially in the lower peninsula, it gets awkward. So they've come up with this other system here called the Michigan GeoRef, and what it has is a set of parameters that shift the graph paper or the coordinate system on a oblique axis. And you can actually see here it's 337 degrees instead of 0 or 90 degrees, straight up and down, straight north and south. So this is actually what this, if I cancel this for a second, this is what these data sets are actually in. They're in this hotline, Mercator, oblique. and it has all those parameters that link to the Michigan GeoRef system. So it's up to you if you want to use that for coordinates. So that's these numbers down in the lower right of your screen, you can. Otherwise, if we keep scrolling down here, you can see that there's the UTM system. And this actually works really well for the Upper Peninsula of Michigan because it almost fits the whole UP into one zone. This is zone 16. And then in the western UP, you shift over to zone 15, and then in these islands here, it would go to zone 17. In the lower peninsula, it's a little bit annoying. So you have the state plane system, which splits the state in half, north and south. And then you've got the UTM system, which splits it east and west. And sometimes they call this the zipper. So a zipper line can be a bit of an annoying thing. So that's why they've got this GeoRef system. But for us up in the UP, we kind of are benefiting from using this coordinate system. So if the center of the zone is here, you can see that there's going to be a whole set of different numbers from the GeoRef system. So it's up to you to decide what you kind of want to use. And as I said, it depends on where you are in an area, what's available, and a little bit of understanding. Now, you don't have to be an expert at this initially. It's taken a lot of years of practice to really get to grips with understanding projections. And in reality, as you keep going down that area, which is called the Geodatabase, you start to go into the surveying world, and more precision is learned and required in understanding. So that's a 4-year process. So keep working at it and you'll get better at it, but have an awareness that projections are fairly fundamental to GIS. Anyway, let's go back to our Geodatabase here, and we're going to create a new feature data set. And I'm going to call this one hydrology. And it's asking me for a coordinate system, and I think I'm going to use, now you may have different favorites from me, but I'm going to use the UTM system because I think it's going to be good for Marquette County. But if you're working in somewhere else, like maybe Detroit area, you would probably use either a different UTM zone, or you could maybe remain with the GeoRef system. So you can kind of see here the two main divisions. You've got flat Earth as projected coordinates, and round Earth, degrees, minutes, seconds, are called geographic coordinates. So we're going to use projected coordinates. You've got your state planimetric or your plane systems. You've got your state systems here. So this is where your GeoRef is. But note that that's based on the 1927 datum. So that's an older measurement system. So you'll actually have to scroll down here and find the one for Michigan in meters with the NAD 83. This use Google as well to kind of find out what these acronyms mean, but HARN means high accuracy reference network, I believe. Let me see if I go out to acronymfinder.com and type in HARN. You can see that high accuracy reference network. That's for surveyors. That's so that they can very accurately locate your property. Now we could use that, but it's probably better we just go with NAD 83 Michigan. And you can see that these parameters here match what was in that PDF file. Now, I know I've gone down that road to show you where the state system is, but I'm going to actually use the UTM, again, NAD 83 for the newer datum for the satellite-based understanding of our Earth shape, and we're going to use zone 16 north. So finish with that, and we've got hydrology. We've got basically a folder that has named hydrology that is specified as UTM. So everything that's going to be in this folder is going to be in the UTM coordinate system. I'm going to create another one here called road transportation. And the same thing, I'm going to hit next on this. Zone 16 north, kind of in the memory, so we'll just leave it like that. And we're going to, so now we've essentially done what we did before, but we've got it in the Geodatabase and feature dataset structure. So what you could do here is in hydrology, you may be able to drag and drop, maybe not, but you can right click and use the import feature class multiple, okay? And what this will do is it will bring up a dialog box here, and you can then use your shift key and drag these two in. And maybe there is a place you could rename them. If you do it one by one, you can rename them one by one, but for now we'll just leave it like that. And what it's actually doing now, you'll see something start up in a minute here, down in the lower screen here, is it's actually taking all those coordinates as GeoRef coordinates, and then it's actually running through some mathematical equations to import them into the computer as UTM coordinates. So let's grab this next one here as well, and I'm going to import feature class multiple, and I'm going to grab so I'm going to go back to the folder I was just using, so CMGIS data Marquette, and this is for roads, and I'll grab the railroads and the all roads and the state roads. So we're going to grab all of that information. Now there's quite a lot of roads, so this could take a little while. So I'm just going to pause the video here. So it took a little while to do I paused the video for a second, but it took a little while, and it then created this structure. So if you go to layout view instead of data view, and let's say zoom to full extent, there's Marquette with all its roads and different things, and you can work on creating a pretty map of that. When you're finished, there's a snipping tool somewhere, and you can use that to grab a screenshot of your map and create a final product. So the video is a little long, but it's an important topic on how to import data and manage geodatabases and feature data sets. So this is the minimum of what you would create in your assignment.